So first what we're going to do is we're going to look at the key features. We're going to look at each of these details here and then see a couple of the screenshots of the things that I find valuable within an FTK that are unique about it. Again, remember, none of this is on the test, and the piece at the end that we want to talk about is the big winner in this section. So this is the list of key features, and let's look at each one of them. Known file filtering. Utility that compares known file hash values against those in your case file. What's beautiful about this is that that hash database says, I know what the Windows operating system ntoskernel.exe, I know what the hash value of that file is. When I'm doing my indexing as FTK, not you, but the actual program, it will go through and it will find those files, and then it will hash those files, and it will say that hash is consistent with what is inside of my database here that I retrieved from the vendor there. Don't look at the files that are correct and consistent. Let's look at the files that are incorrect, inconsistent, and may be corrupt or may be used for something else. It may be that somebody creates a file called ntoskernel.exe and it's really just a text file. This tool will go in and it will hash that ntoskernel.exe file with the wrong extension on it. It will hash it and say this hash value doesn't match. Take a look at this file. Now sometimes this fails. The known file filtering fails because of updates and service packs, but they're pretty good at pulling this information down. You can also immediately know contraband files at that point. FTK does a really good job of dealing with large forensics labs that are doing multiple cases at the same time. How do they deal with this? Well, what they do is they take off the SQL, I think it's an SQLite database engine, and they put on an Oracle database engine. So you're going to need a copy of Oracle to install, and you're going to need to pay for that licensing. But if you've got hundreds of files all running at the same time, you need a big database behind the scenes to hook onto this as an engine. I think that's an excellent way to deal with this particular tool. Also, if you're doing password cracking, you can use what's called the distributed processing engine, which will allow you to take this password file that you're trying to crack and pass it across 3 different machines all at the same time. So 3 additional computers can be working on cracking this. Each one of those computers could have installed in it multi-core operating systems. So if you've got 12-core or 16-core operating systems and 3 different 16-core hardware out there, you can go ahead and split that across those 3 different servers and let them do the hardware cracking for you. It does a good job of decrypting files inside the examiner. If you've already got the username and password, the automator will walk through any BitLockered files that are actually there. So if you know username and password, you can program them into the tool, and it will automatically decrypt them and allow you to review them and tell you that you're working on an encrypted file. They also have something called photo DNA. Now, this works on a lot of CP cases that are out there. What happens is there's a lot of known CP out there that has a hash index against it that's created in a database of about 11 gigabytes of files. And in photo DNA, what we say is these files were downloaded from the internet, and we can actually do a hash value against those photo files and compare it to that reference database of CP, and all of that information will say this is a known file that matches up with a known file there, so that we know that this is CP. If it doesn't match that DNA database, then you'll have to inspect. But if it does match and you see lots and lots of occurrences of it, you don't have to actually look at that file, because some things just can't be unseen. Exporting and importing index search terms. Now, here's the thing. I told you about the indexing, but you're a forensics expert. You know the slang that we're talking about. You know that bit-for-bit copying. You know what imaging is. You understand those things. But do you know the latest term for this illicit drug, that illicit drug, or this illegal thing? Do you know the slang of the gang that is in that particular area where they've acquired that evidence from? And do you understand that, and have you heard those terms? No, you're a forensics person. You're a computer person. You have no connection with that world. You're doing this technology here. We'll turn around to the law officers that are involved and say, okay, what's the slang term for this? What's the names for this particular street drug? Give me all the different ways that that's there and all the different spellings of it. Let's catalog all that information. We'll collect up all that data and we drop it into our indexing and our search terms, and now it can look across that. Because if you're looking for the word drug, they might never write that word down inside of that Excel file, but they'll certainly write down the word chronic or whatever else it is that's out there. You don't speak that language. You're a geek in a cube. Stay in your cube. Let them tell you that language, and this tool will go and search through that index for you if you can program in those words.